Thank you, everyone, for joining me. And today, we are going to talk about creating a composable and modular platform. We will talk about in depth what it's about. But it's another platform engineering talk focusing on developer experience. If you just watched the previous talk, we're going to have lots of overlapping topics. I will try to speed up a bit. But why dev experience? It has been the main talking point of last few years, why it matters, why it's important, because it's all about how we enable developers to use our platforms. We don't build platforms or platform engineering for fun. Yeah, don't get me wrong, we build platforms because we love it, but we build it for developers to deploy their applications, recently deploy their AI models, and etc. So it's about improving them to boost their productivity and to also improve the software development lifecycle and shorten the time to the market. Shortly about myself, my name is Hossein Salahi. I'm a consultant in my daily job. I work as a tech lead. And yeah, last few years I've been contributing to the open source community, and that's what I do as a hobby next to my job. So today we are going to take a look at what are the current challenges in cloud native ecosystem and what developers are facing these days based on the current created platforms. We will quickly recap what we know about platform engineering and internal developer platforms. We will take a look at how community took a step to create reference implementation for IDPs. We will take a look at two main projects in this area. One is focusing on how to build capabilities, backend services by the platform engineer. The other one is focusing more on the making those services, those backend processes more visible to the end user via Backstage. And we will take a look how we can mix these two powerful projects to make a framework that helps both platform engineers and both developers to achieve more reliable, maintainable, and reusable platforms. Last but not least, we will have a demo. So let's take a look at what we know from the past, from the history. This is typical DevOps model we know from our companies, from our organization we are working for. So at the right side, we have admin teams. They do and they design, they build managed services in our companies based on on-prem infrastructure or cloud infrastructure. They use infrastructure as code or other cloud-native toolings to create those services for us. They use CI/CD pipelines, they use automation to make those services available for developers. How we expose those services? Usually in a really bad way. So developers, they have to write emails, they have to create tickets to get access to those services. I've been visiting lots of customers back in Germany. I've been talking to them. They have built super complex platforms. I've been talking to them and asking one simple question. So you have built really nice platform, but how you expose it to your end user? How developers can be onboarded to those projects? They didn't have any answer. Email, tickets, takes 1 week, that's not the answer. Bottlenecks. Of course, in such a model, the platform engineering team or DevOps team, they become easily a bottleneck because they cannot handle so many requests coming from developers. I want these stack of managed resources. Some are really customized, specific, so that makes life tough for both sides. This is where platform engineering came in. So the focus is to using the same principles, the same tooling sets, same workflows we know from DevOps. Nothing new, but to put more discipline on that. Create a layer of abstraction on top of underlying infrastructure, the services we built so far, and make it more simplified. And the main point is that to adapt to golden paths or paved paths that we talking about in platform engineering, to make this a unified, automated, scalable, reusable environments for everyone. Of course, customizable. So you define your own templates, you put the guardrails from the beginning by the platform engineers, and at the same time, you give the possibility to the developers to customize those services. And of course, you have to make it self-service. I don't want to write ticket. I don't want to write emails. So I want to get resources I want as quickly as possible. And this boosts exactly what I talked about. This exactly improves the developer's productivity, because you are really boosting the process to make those resources available for them. So this is how platform engineering is going around those problems. So we know from our DevOps, from the classical cloud infrastructure, we have different teams. One team is focusing on cybersecurity, the other team is focusing on monitoring, infrastructure, database, DBAs, etc. So platform engineering is putting all of these teams together and creating one layer on top of that, which is the platform. And that's where exactly where the developers, end user are going to contact. So going in more to detail, so this is exactly where we are ending up. The result of those efforts from platform engineering is an internal developer platform. So at the bottom, we have the cloud infrastructure, nothing new. At the middle, we have those managed services, the capabilities, the cloud resources, the workflows, many different managed services that the platform engineering team is going to produce and make it available. And on top of that, we have, again, this thin layer, which is how we expose it. In the previous talk, my colleagues, they talked about it. How do you make it available? Through APIs. This is the way. Doesn't matter which API. Is it Kubernetes API? Is it API that you wrote by yourself? So to consume it, you need API. On the other hand, you can also expose it via portals, such as Backstage. So think about IDP as an operating system. So for example, in Linux is just a set of software binaries that they are based on a Linux kernel. And of course, it comes with a packaging, the package manager around it. And it's the same for IDP. We have the same bunch of software tools. They are using Kubernetes as their base platform. And there is a huge tooling ecosystem around it, which is coming from CNCF Landscape. So looking at the IDP, we can just outline some of the technologies we are already using. So application configuration management. So we are using Git for versioning. We are using secret management. We are using guardrails, such as Kyverno policies. We are using the same principles, infrastructure as code, CI/CD pipelines. We are using the commodity cloud services, such as DNS, and etc. And at the heart of it, it's again the self-service, how we expose it, how we make it easy for developers to consume it. And as I said, the putting the guardrails since the beginning is one of the main focuses. So you tighten up your platform since the beginning. So this is one of the reference architectures from the platform engineering community. So they are, the architecture is evolving all the time, but we can see two different groups. One is the upper layer, which is what we expose to the customer, to the end user, which is mostly developer focus. We have the developer portals, such as Backstage, and some other toolings in the ecosystem. We have the Git versioning systems. We have the infrastructure as code tooling, such as Terraform or Cloud Native Way, such as Crossplane. And we have at the bottom part, we have the part that is more focused for platform engineers. We have a great tooling set. We have some projects that you are working every day with it, such as Argo CD, Flux for continuous delivery, and some other tools that helps us to build the services, the capabilities that our platform needs. And of course, we cannot talk about a cloud platform without talking about observability, networking, security, and some other base capabilities that the platform requires. So let's take a look at some of those efforts that ended up as a reference implementation for IDP from the community. In the previous talk, the colleagues, they showed the CNU, one of the reference implementations. So what is common between all of these toolings is they all are based on Kubernetes. They are both extending the same API that we all know. So nothing new about it. They are all using the custom resource definitions to extend the Kubernetes capabilities. So today we are going to talk about Kratix, the project that I've been working for a while. So what is Kratix? It's an open source framework. So the term of composable, what does it mean in terms of IDP? So when we are building a complex platform, it's really important that we put it into small pieces. So let's say small services or capabilities, and that's where Kratix is focusing on. So you can build really complex platform, but you need to put it into pieces, and through that way you can make it more understandable and simple. So if you look at the Kratix-based concept, so as I said, it's using the same concept of custom resource definition by extending Kubernetes API. So nothing new. So at the core of Kratix concept is the promise. It's think about it as a developer, I want to consume an API. The promise is the claim or the request that I'm writing to this API to be able to get the resources I want. So dependencies is about which dependencies for my promise should be pre-installed or configured before I can fulfill my promise. And the action is focusing on the real resource. So imagine when my promise is focusing on creating a database in AWS or using an operator inside Kubernetes, which action should be taken from A to Z that I get my resource created in the cloud provider, and I get access to the real resource. And destination rules, I will go into depths of destination. And later, it's more or less focusing on where this should be created. So this is example of promise. As we talked about, it's using the same semantic that we know from Kubernetes. The extension of API, the dependencies. So what are the dependencies for my promise to fulfill? Which actions should be taken before I can use my promise? Workflows, what should be done to get the resource created? And where this should be deployed. So this is the base architecture coming from Kratix. So from platform engineering perspective, we create this predefined routes. So I would like to create the resources that I want to be integrated into my platform and then be exposed for the consumer. So this is how it looks like. So I use the Kratix, I define my promise, and then based on my promise, the next step is focusing on to creating those resources. So as example, this promise is focusing on creating a deployment, an ingress object, and service YAML. And about destination, as I talked earlier, so destination for us means where this resource should be deployed. Destination is the target cluster I want to use it. As we all already using the GitOps concept, the agents from Argo CD or Flux, so we should have our agents running on the target clusters. And as those resources are created, they are stored either in your Git repository that we all use as single source of truth these days, or you can use your S3 buckets or any S3 compatible backends. And the GitOps agents are pointing to those storages, either Git or S3, and they're able to fetch those manifests and deploy it into the destination cluster. So what I love about Kratix, they have really strong marketplace. So technically, you don't need to create something yourself. You can just jump into the marketplace. You can see they have a bunch of promises already written. So shortly about promise. Promise is nothing new that you don't know. As I talked about it, it's just another layer of abstraction. It's packaging that they wrote themselves. But if you go at the depths of the promise, you will end up seeing the operators in their repositories. So, for example, A promise, it's focusing on creating a Kafka for us, is using a Kafka operator in the backend. So from that perspective, there's nothing new. So this was more about focusing on the platform engineering side from the platform engineer perspective. So what about the end user? So that's where Backstage comes in. So Backstage is a project that developed initially by Spotify and then later donated to the CNCF and now is a CNCF project. So it's mainly focusing on bringing visibility to the services, to the workflows, to the capabilities that we built earlier and how we make it exposed to the end user. So this is what I earlier asked my customer. I said, how do you make it visible? So as a developer, I need a central portal. When I want to onboard a developer, this is my first contact point. So you don't need to look at some wiki pages or some Git repos to find out how you can utilize the services that your team built for you. That's the main focus of Backstage. The self-service capabilities of Backstage is the shining part of Backstage. It makes the things easier for developers to understand and boost their productivity. And of course, it also reduces the cognitive load by providing the standard toolings or services that we built earlier. So it really helps to speed up the onboarding time. So looking at the Backstage core concept, so the first part is the core, which is coming from the open source project. So the core functionalities that the team that they're developing, they have already integrated. And the second part is the application. It's the instance that we deploy by, when we are running Backstage, it's the instance that we deploy. Usually when you run Backstage, you will just get some default dashboards, templates, some standard software catalog coming from Backstage, but we can customize it. That's where the power of Backstage is. And the most important part of Backstage is the powerful ecosystem of the plugins. So you can plug in your already existing platforms, workflows, CI/CD pipelines, Kubernetes clusters, Argo CD, observability stack that you already know and use. You just need to define the front-end plugin, the back-end plugin, which already developed by developers from the open source community, and you just need to integrate it. So about the Backstage philosophy, this is what Backstage, Spotify philosophy is. It's all about interface. It's all about how we make things visible and accessible in a single portal and single dashboard. It's about autonomy. So when customers ask me, oh my God, we have heard about this cool project Backstage. And we have around 300 developers. Is it possible to run multiple instances of Backstage per team? Imagine they have 10 teams and they want to run 10 instances of Backstage. I say that's not a good idea because Backstage is not an easy or light baby to handle because it comes with lots of cognitive load and complexities. It's important to know that a Backstage philosophy is based on autonomy. So you don't build the platform only from the platform engineering team side and say, okay, this is the platform and use it, not a top-down model. You enable your developers, your engineers to bring their own plugins, to integrate it and connect to their own ecosystem. So that's the power of the Backstage. So if you look at the Backstage ecosystem, so there are three main components that are outstanding. So the first one is the components part, which are the parts of our software catalog. So technically, they are pointing to some backend service or website or libraries, that we know. So the resource part is referring to real resources that we are creating out of Backstage context. So they are the real cloud resources or Kubernetes objects that we are creating. And the API is how the components are communicating with each other in Backstage context. So we talked about Kratix. we talked about Backstage. Is it possible to use Backstage as a front end and Kratix as back end systems? Yes, we can do it. As we said, Backstage gives us this unified, seamless experience in a declarative API. That how we utilize the services, the toolings, the documentation that our platform team has already built for us. From the other side, the Kratix is extending Kubernetes API, the same semantic that we are using for Kubernetes to build the capabilities, the services for our platform. And by combining them, we are building really powerful framework that puts the user experience at the front. So the main focus would be how we can improve the developer experience. And this is a really great concept because we push the UI focus more into Backstage, how we can create our dashboards, how we can integrate plugins through Backstage, and we can more focus on the API from the Kratix API side, and this improves, of course, the maintenance. So by putting these tools together, so we will end up having such an architecture. So platform team, they are creating templates, these predefined routes. They put the guardrails, they store all those objects inside Git. From the other side, Backstage is able to connect to that same Git repo using the software catalog and access those resources. And when a developer wants to create a resource, interacts with our central portal, which is Backstage in this case. And any request coming from Backstage ends up at Kubernetes API, and that's where Kratix knows what to do. When a promise is landing at Kubernetes API, Kratix operator knows, okay, this is the promise, I need to create a new instance of Jenkins, I need to create a new instance of Kafka, or I need to create an instance of managed database at AWS, or a Redis database out of the cluster. So going back to the first slide, a composable and modular platform is possible through putting these two powerful frameworks together. As we saw, Kratix is helping us to build our platform, services, capabilities bit by bit. That's where the promise coming from Backstage is helping us. From the other side, Backstage, by more focusing at the visibility and UI is allowing us to make it expose the backend services and the workflows we built internally more exposed to the consumers. So I prepared a short demo. I hope everything will work fine. Are you able to see the terminal? Yeah? Okay, good. So that's technically where my Backstage, is it big enough? Good, that's where my Backstage instance is lying down. So I have integrated already the front end and back end for Kubernetes cluster. So I have running local Kubernetes cluster by Colima. It doesn't matter, it can be your Minikube or Kind or whatever. So that's not the main point. I just need to update my kube config because the token probably has already expired. So that Backstage will complain. So I'm just going to start my Backstage instance. I hope everything goes well. So yeah, there we go. So I have created two simple templates. Imagine I'm a developer and I want to just onboard into a Kubernetes cluster. And let's say we are adapting to multi-tenancy concept. So there's a big cluster and I want to just get a namespace, and that's my namespace for my use case. So this is one case. So the other case is that I want to deploy the same, in the same namespace, I want to deploy a Postgres instance by using Postgres operator. So this is what we will do right now. So I will just go back to the main. I would like to create a Postgres instance. So the name let's put it demo instance. Is it big enough? Or I can just zoom it more. So, and I will just use my demo cluster as the destination. So this is where I would just like to create a Git repo for my tenant. So let's call it demo instance. And let's hope this will work. Yeah, live demo. What can go wrong? So I know exactly what happened. I think my token is still not updated. But yeah, that's technically the case. I can just go back to the cluster. I can show you what I have created previously. So if the process was successful, it was just about Backstage contacting the Kubernetes API and deploying Kratix promise. So I can just quickly show how that promise technically looks like. So this is an example of the promise coming from, this is technically what all I need to write. So this is the definition. And this is what I need to just give to Backstage, as a template. So I just say I want a Postgres instance, and this will be created at the destination cluster. So if I just look at and get Postgres instances, I hope the cluster is running, yeah. Postgres SQL. Yeah, there we go. Nothing. Okay, that's not good. I just need to. Yeah, I can see that the Postgres operator technically is running in the cluster, so it can receive requests, and I can do it by manually deploying this. So this should create us the new instance. So this is what the Backstage is supposed to create for us. So this is our Postgres instance. So if you look at the definition, is exactly what we saw earlier in the Git repo. Nothing new, just with some more metadata added by the operator. So if you look at the end, so we have, the instance created. So going back to the slides. So let's recap what we talked about. So it's all about using this modular or composable platforms by using these two tools. So it gives us the possibility to define our platforms bit by bit. Small pieces by using the Kratix promises. From the other side, using the Backstage to make it visible. What we built internally, it doesn't matter if it's super complex or how cool it is. If you cannot show it to your developers, if you cannot be consumed by them, doesn't matter. So the main focus should be how we can build it and how should we expose it. And at the end, the main focus is always on how we can make the developer experience improved and how we can shorten the time to the market. Questions?
All right, great. Thank you for the talk. So we saw that, if I'm understanding things correctly, you create a promise in Kratix, and it basically turns it into a CRD on the cluster. That's very similar to what Crossplane is doing with claims. So can you maybe talk a little bit about what differentiates Kratix from Crossplane and what the main differences are?
So what Kratix does compared to Crossplane is the same concept. So let's say you want to deploy an RDS instance with Kratix. Kratix handles the deploying the controller also by itself. So Kratix has clear dependencies. So you say, I want to create an RDS instance. Kratix already knows, okay, the dependencies are that first I need to deploy the control plane, let's say Crossplane. So they already have the chain of dependencies. So it tackles the other side. So it makes the life easier for platform engineers. So from platform engineering side, usually we have to deploy the controllers for Google Cloud, for AWS, for Microsoft. So that's where the Kratix takes the load off from the platform engineering team.
Cool, thank you. And if you have a minute, it would be interesting to see what like a longer example of the dependencies resource would look like in like a real, more like a bigger version.
Sure. We can take a look later.
Thank you.
Yeah, hello. I'm from AWS. Just so you mentioned this GNU, actually. So I just want to know what's the how the Kratix difference with GNU from your point of view.
I also already worked with GNU for a couple of months, and I love the project. I have to say, they have lots of similarities, I would say, from the design, from the concept. I mean, they both are using the CRD concept, and they have lots of similarities. What I love about the GNU compared to Kratix, I mean, the GNU enables you to generate, the backstage, the resources also. So that's where I'm missing right now by Kratix, because that part is enterprise at Kratix.
Okay, thank you.
Sorry, in this scenario that you show, what is the main need of Kratix? Why don't we use just Backstage and only use it without a Kratix?
The main focus, the people who are also familiar, with Crossplane, these composite resources, the main focus is how I can put all the life cycle of my, let's say, my application, because with Kratix, you can also deploy your application, yeah? So I put my application, the dependencies, the cloud services, all the, backend services or whatever I need, I put it into one simple YAML. So somehow I put all my claim into one file. So that's the main focus.
Okay. Instead of making complicated Helm charts, you just need to use Kratix for these scenarios?
I would say, I mean, we are talking about two different patterns. So what Kratix is using is based on the Kubernetes operators. So if you look at the Kratix Promises, if you just go to the Git, you can see that they are heavily based on, the community operators, like Postgres operator, like Kafka or the others. So of course you can use Helm charts, but my experience coming, from last 10 years of cloud native, saying that adapt to operators as much as you can, because they manage the life cycle of your tool or your platform by the operator.
Thank you.
You're welcome. I think that's it. Thank you so much.